All right, gotta admit, when you first sent over this article on slide rules, I kind of thought, okay, history lesson, cool, but relevant to me, not so sure. But then I started reading this piece, Precision and Patience. What slide rules can teach today's students?
Yeah.
Whoa.
Yeah.
My mind was blown.
It is funny how something that seems like a relic of the past can actually give us clues to improving learning today, right?
Exactly. And it got me thinking. I was terrible at math in school. Like formulas would just swim around in my head.
Right.
Maybe if I had something like a slide rule, something hands-on, things would have clicked better.
That's exactly the argument the article makes.
Okay.
It dives into how that tactile nature of a slide rule can bridge those learning gaps, especially for folks who, like, you learn best by experiencing.
So let's back up a bit for anyone who, like me 5 minutes ago, is picturing some dusty museum piece.
Sure.
What exactly is a slide rule?
Well, imagine a ruler, but way cooler. It uses these sliding scales that are marked not in regular distances, but in logarithms.
Okay, logarithms. That's usually where I check out mentally.
Right.
Can you break that down for us non-math whizzes?
Think of it like zooming out on a map.
Okay.
You could fit a huge amount of land onto a small piece of paper, right?
Right.
Logarithmic scales do that for numbers. They let you work with huge EE values in a compact way.
So it's like a number line, but it's been like squished and stretched in a very specific way.
Exactly. And by sliding these scales against each other,
Right.
you can do multiplication, division, even more complex stuff, all by physically moving these pieces.
So instead of memorizing times tables or plugging things into a calculator, you're literally seeing how the numbers relate to each other.
And that's where it gets fascinating.
Yeah.
Because the article argues that this visual tactile approach can be a game changer, particularly for students who struggle with those abstract math concepts.
Okay. I'm starting to see the connection to modern learning.
Yeah.
We're so focused on digital tools on screens.
Right.
Maybe we've lost some of that tangible connection to the things we're learning.
The author makes a strong case for that.
Yeah.
But to really appreciate it, we need to go back in time
Okay.
to the slide rules origin story.
Oh, so now we're really going back to the museum.
We are.
Hit me with some history.
1622, William Oughtred invents the slide rule,
Okay.
building on the work of John Napier, who discovered logarithms.
Okay.
But here's what's wild. Back then, math was seen as almost mystical,
Okay.
intertwined with alchemy and the occult.
Wait, so like they thought math was magic?
In a way, yes. Their view of math wasn't so different from how some people feel about it today, intimidating, full of secrets.
Okay.
But the slide rule, born in that context,
Yeah.
was a way to make those secrets tangible, manipulable.
So we go from seeing math as mystical to holding it in our hands, literally sliding the answers into place.
Yeah.
That's kind of poetic when you think about it.
Absolutely.
Yeah.
And over the centuries, the slide rule evolved, got refined, until by the mid-20th century, it was the tool
Right.
for scientists and engineers.
Oh, right. Didn't they even use slide rules for the Apollo missions?
Exactly.
Wow.
Think about that, putting humans on the moon,
Yeah.
using a tool that at its core isn't that different from a fancy ruler.
That's incredible.
Yeah.
It really speaks to the power of these analog devices and how they can foster this deep understanding, this precision that maybe we're missing with just pushing buttons on a calculator.
And that precision, as you mentioned, stems from how the slide rule works.
Okay.
Let's take a closer look at those scales.
Okay.
The C and D scale specifically,
Okay.
because they're the heart of the operation.
Okay. I'm ready to get into the nitty-gritty. Show me how this thing actually calculates. So imagine these two scales, C and D, like number lines, that slide against each other.
Yeah.
But instead of even spacing, they're squeezed and stretched according to logarithms.
Precisely. And to multiply, let's say 2 times 3, you find the 2 on the C scale. And slide, so it lines up with the 3 on the D scale.
So you're physically like matching those numbers up?
Right.
I'm already starting to see how this is more visual than punching it into a calculator.
Exactly. Now look where the 1 on the C scale lands on the D scale.
Okay.
Boom, you've got your answer 6.
Whoa. That's kind of wild. You're turning multiplication into this physical action, this movement. I can see how that would make it click for some people.
And that's the beauty of it. It forces you to engage with the relationship between the numbers.
Right.
To see how changing one affects the other. It's not just spitting out an answer.
But the article isn't just saying, hey, slide rules are cool. It's making a bigger point about how we learn right.
Absolutely.
Mm-hmm.
The author Jaime Hoerricks actually uses slide rules in their own classroom
Really?
to teach Algebra the Second.
Wait, really? High schoolers are using slide rules. What's that like?
Hoerricks describes their students' reactions as pure astonishment.
Wow.
These kids are used to digital everything. And suddenly, they're faced with this analog tool that's older than their grandparents.
That must be a shock to the system, but a good one, it sounds like.
Exactly. The students are amazed by how the slide rule makes something as abstract as logarithms seem so concrete,
Yeah.
so understandable.
It's like it demystifies the math, turns it into something you can see and touch.
Precisely.
Mm.
Hoerricks even mentions a student who said, "The slide rule makes everything clear. My textbook and calculator don't do that."
Wow. That's powerful.
Yeah.
It makes you wonder if we've lost something in our rush to embrace digital tools, if maybe some learners are being left behind.
That's a key point Hoerricks raises.
Okay.
They argue that while technology has its place,
Yeah.
it shouldn't come at the expense of hands-on learning, especially for those who struggle with abstract thinking.
But let's be real, even if we all agree that slide rules have merit,
Right.
how practical is it to bring them back into classrooms? I mean, they're not exactly lining the shelves at Walmart, are they?
That's the challenge, right?
Yeah.
Hoerricks acknowledges this, even expressing a longing to have a classroom set of slide rules so every student could experience them.
I get that. It's one thing to see a demonstration,
Right.
but another to really wrap your head around it by using the tool yourself.
But even with limited access to slide rules,
Yeah.
Hoerricks sees their value not just for teaching math,
Okay.
but for instilling certain qualities in students.
Like what? Persistence? A
Yeah.
love of vintage things?
Well, those two, perhaps.
Yeah.
But more fundamentally, things like patience,
Okay.
engagement,
Hmm.
curiosity, and a focus on the process rather than just the answer.
It's like the slide rule embodies a slower,
Right.
more deliberate approach to learning.
Yeah.
Which is like the opposite of our I need it now culture.
Exactly. It forces you to slow down, to think through each step,
Right.
to appreciate the journey as much as the destination.
And I bet that translates beyond just math, right?
Well, absolutely.
That kind of mindset could be beneficial in any field, any learning experience.
Absolutely.
Yeah.
It's about developing a deeper understanding, a genuine sense of how things work,
Yeah.
rather than just memorizing facts or relying on those shortcuts.
Okay, so we've talked about the history,
Huh?
the mechanics,
Yeah.
the benefits,
Yeah.
even the nostalgia factor.
Hmm?
But the article goes beyond just praising the slide rule.
Right.
It actually connects it to some pretty strong critiques of modern education.
Right. It's not just about romanticizing the past. It's
Mhm.
about looking critically at how we're teaching today and recognizing that maybe we've swung too far in the direction of technology at the expense of other valuable approaches.
So it's not slide rules, good technology, bad.
Yeah.
It's about finding a balance, right?
Exactly.
About recognizing that different learners thrive with different methods.
Precisely. And that's where the article gets really interesting
Oh.
because it goes on to offer some concrete solutions
Okay.
for incorporating tools like the slide rule into today's classrooms.
Yeah.
Even with the limitations we discussed.
All right, I'm all ears. How do we bring back the slide rule, realistically, in a way that actually benefits students? So how do we practically bring back something like the slide rule, given everything we've discussed?
Well, Hoerricks suggests a station rotation model
Okay.
instead of a whole classroom set.
Yeah.
Imagine a few slide rules set up at different stations during a math lesson.
Okay.
Students can rotate through, get some focused small group time with this hands-on tool.
Ah, so it becomes more of a special activity, a
Mhm.
chance to really dive deep with the slide rule.
Exactly.
It wouldn't be overwhelming for the teacher to manage either.
Exactly. And what's great is the slide rule isn't just for advanced math.
Right.
Remember, it can be introduced even in elementary school.
Right. The article talked about using it for basic multiplication and division, building up those foundational skills.
Think of it, instead of just memorizing times tables,
Uh-huh.
a fourth grader could slide the scales and literally see how 3 times 4 equals 12.
Yes.
It's visual, it's tactile, it's engaging.
And then as they progress, they can use it for fractions, decimals.
Right.
Eventually all the way up to trigonometry and beyond.
Exactly. It becomes this recurring tool
Yeah.
that helps them develop that number sense,
Right.
that intuitive understanding of how numbers work.
It's like they're building a relationship with numbers, not just memorizing formulas.
And what's exciting is it's not just confined to math class.
Oh. Where else could you use a slide rule?
The article talks about using it in geometry to teach trigonometric functions.
Okay.
Instead of just looking at angles and triangles in a textbook, imagine students using a slide rule to physically manipulate those relationships to see how changing one angle affects the others.
That takes it from abstract concepts to a tangible experience. It's like bringing the math to life.
Exactly. It's about making those connections, both mental and physical, that help the learning stick.
So the slide rule, it's not just a relic of the past. It's a tool with real potential for today's learners. I have to say my initial skepticism has officially vanished.
I think that's the beauty of this whole discussion.
Yeah.
Sometimes we have to look back to move forward, to rediscover those timeless principles that make learning effective and engaging.
The slide rule in its simplicity encourages you to slow down,
Right.
to really think through the process, to understand the why behind the what.
And in our world of instant answers and constant distractions, that's a valuable lesson indeed.
It makes you wonder, what else might we rediscover? What other tools or approaches might be hiding in plain sight, just waiting to be brought back to life in the classroom?
That's a fantastic question. It's a reminder to be open to different ways of thinking, to challenge assumptions, and to never underestimate the power of a fresh perspective, even if it comes from the past.
Well, this has been an incredibly insightful deep dive. Thank you for joining us on this journey into the world of slide rules. It's amazing how a seemingly simple tool can spark such a profound conversation about the nature of learning itself.
It has been a pleasure. And as always, the real value is in the questions it raises, the connections it sparks, and the inspiration it provides to keep exploring and learning.
We hope you've enjoyed this deep dive and perhaps even feel inspired to rediscover the magic of hands-on learning. Until next time, keep those minds curious and remember, sometimes the oldest tools can teach us the newest tricks.